Hi, welcome. On this video, I'm gonna go to a second video of Java Compute Node. I just wanna re-emphasize, make sure that you guys know the basic Java, whatever Java, like how to use the variable in Java, how to create function, and also know the also familiar with the concept of object-oriented language. So let's start it with the second video on this is the IBM JavaCompute code. Just we open it, and first we have a few package like 6 and 7 package. The first package is a IIB JavaCompute node. IIB JavaCompute node, we have a class. I create this class by name as message flow JavaCompute node. We extended the IIB JavaCompute node. Whatever classes and interfaces on that one, we will implement it to our classes. So this is the super class that we extended, and we have an IIB element. This is for the message element, and what we do, we will manipulate the data is coming. We will manipulate the way we want it. And this is a IIB exception. And IIB, like a compute node, IBM create their own IIB exception package classes. It is like anything happen, they will throw that exception according to the rule that apply. For example, let's say we want to write something that we're not supposed to write, like to IIB assembly, especially on a message, end message, they will throw the message like IIB read only exception. And this is an IIB message. This has a property and content. We will manipulate a property and content, so all the property and content will come to IIB message packages on a classes. And also we have a IIB message assembly. This is one of the more important one, because in this one, this represent 4 type of data. Let me send the message. What I mean by that, just like send this one, nothing else. If I send that one, all this data would be representing through this IIB message assembly class. Message will have a more data in it, property, XML, and domain. And we have a local environment, which is a local environment, and we have a global environment. Global environment referring to environment. When I say global environment, that means environment. And exceptionless referring to exceptionless. So all this data will come through the IIB message assembly classes. If you pay attention, we pass it to evaluate method, and we name it in assembly. We will go more on that in assembly. Literally, you could check this name of this your argument if you do not like it. And we have a message broker output terminal. This is for the terminal routing. We could route it to any terminal you want, but we have a 2 terminal, alternative terminal, out terminal. This one we do not use it, I uncommented, and this is something IIB output terminal which we use it. We pass it the terminal right here, and we have a IIB user exception. This is a user defined exception. This allow us to write our custom user exception. So this is a IIB user exception package class, and this is a domain type. This IIB domain that would come, but still we didn't use it. I write some code, that's why this package get imported. Otherwise, you could comment it if you don't want it. And we have a class. Class name is message flow Java. This one once we creating, we give this name to it, and we extended one of IIB JavaCompute node. And on that class, we have a function, we call them evaluate. All the data, anytime we run it on a message flow, that on data on message flow will run through this function. Like we pass it through right here, we name it, we will use that one on different place. You could change that one according to your needs if you want to, but make sure. we threw exception if something happened, and we will go on exception too, but let's focus on the basic first. We have a MB output terminal. We create a terminal, and we create the object. We pass our terminal name right here. If I add alternative right here, it will route it to alternative, but alternate terminal. And we have our out terminal right now. We have a MB message, MB message, then the name of it, and nassembly.get message. What this does, this would get this data. You see, message assembly. This whatever data you send, property XML. These are like, I already explained, like when you're sending a message to the IBM IIB, they're not only you sending this message, only this one. The IBM IIB would create metadata about this message that you send it right here. We send the property, we send the HTTP input header, where it comes from, all the domain information, the service information, and property about all the information is based on that, like a metadata, data about data. It is about that they send it with this. All sign it right now in a, it come on an assembly, which is 4 data. All the data is come on that. We just specified it to route. We want to get only this data. Want to assign it to an assembly. Only this data, which has like 3 root 1, 2, 3. Sign it right here. Now we create. This is the default constructor, empty default constructor. There is like nothing yet we assign it, but we create new empty message. For the reason, whenever n message is coming, we will create out message based on n message and will manipulate it according to our need. And this is an MB assembly, output assembly. There's a copy MB assembly constructor. There's a copy constructor. What is that? If you pay attention right here, the data come from outside. And MB master assembly package, the classes that they create, they pass it right here. The same way the data come from outside, we will send it to outside. From outside to inside, we will send it from the outside to from inside to outside. So we just create this one to create again our out assembly. Like this was the n assembly data come right here. This is our assembly where data will go from right here. What I mean by that, like the data which we assign it right here, and also the output we will manipulate this data. Because this data read only, that's why we take the copy, we'll manipulate it, assign it to output terminal, we pass it back to the output assembly, and I send it through terminal. You see, send it to terminal, output terminal. We just create object, we send it through that. And right here is a try and catch. Try and catch, this is the one method they create, which has an end message. This is optional also, they say. It's optional, you could delete it, all that. And out message. We pass the end message and out message. The out message is empty, end message has this data in it. Let's see what is inside. On this data, we because we pass again as a class as an object argument to that, we just pass that one and MB message assembly, and we pass the data which we assign it to this object end message, all this data, and we create out message based on the empty constructor default. That was the default constructor. One thing I wanna mention before we get to this one, once we say like get message dot get root element, it equal to this one, like input message on a ESQL code. Once we said ESQL code, this one like output message, like data that we want to send it to, like data that is coming, we'll send it to output and send it outside. So that means whatever this data is come, like all the metadata on a domain, they will assign right here, they will send everything. Right here same thing, like when I say when we say get message dot get root element, of course we will say the n assembly first, like the way I said n assembly n assembly, because we sign an n assembly dot get message. Then after get message, After get message, we will say get message dot get root element. When we say get root element, this one just we come to this position. To this position, everything of this one. Root element is this is all the root element. This is for that one. And the second one say get message dot get root element, get first child. This is the first child. We get to a body. Say get first message, get root element, get first child. We get to this position. To sign this one, like to get to a body. And if you say get local environment, that means this one, local environment. Get root element. Always you must say get root element. This is the, like, go to a local environment, then go to a root element. Whatever root element is it, get it to that. And same thing, in assembly you must say that with everything. In assembly dot get message, in assembly dot get message root element, in assembly dot get local environment dot get root element, and that is equal to input local environment. And we have a get local, get global environment dot get root element is a similar like environment. And also we have a get exception list, which is a get root element, and an exception list is the same thing. Repairing to exception list. So right now, if you pay attention right here, what it does, that was for the end message. The data that is coming, that way we will get it. But the data that is going out, we will create it this way. We create a constructor empty. We create the object by default constructor. We have it empty default constructor. We create the empty one. After that, you see we said MB message, this object we create, and after that we will say get out message dot get root element. Then we create to this position, to root element right here, but still we didn't sign yet. We didn't create any root element. Just we up to this point we created root to this point. Let's say to, and if you want to create it, then let's go down. You will see it, but just remember to this point we get it. And right here what we do, we create a header, say n messages and got root element, which is, you see, got root element. We get to this position. If you say get first child, go to root element. On a root element, this is the first child, this is the last child, and this is the next sibling. If you say get first child, then get this property and assign it to the header. And they use the while loop on a Java. You could say while this is the body, this is the body, this is the condition, this is the body. So don't get confused. You could write any code in that, like one bigger than two. Then do, if that is through your, go to your code and write some code. So if you come right here, copy a header and add it to the output message. Now we will copy the header. How we will copy the header? So get new header. We new header because we want to create to our output terminal. We will, and output root dot, you see we created up to this point we did not create it. We just get to the root element, to up to root element we created. Now we create element as a last child. So we will create out root element as a last child and header dot get parser class domain. So and we pass the header. So what is that? Say create the root as a first child, whatever on this one created as a last child, because since there's on a my child, when there's a nothing exists on my root because we just created. When there's also is a first child, when there's an, for example, suppose there is a only property, there's not XML, HTTP, and there's no XML NEC. If there's only property, there's a first child and last child. You could say one first child, you could say one last child. Either way is fine. And so what we get, we will sign whatever data that was coming on first child, which is this. Then whatever type of parser is right here, we will just copy same thing to our new header. Then we will get the same element. They call them property. Then when you say header.get name, they will get this property. Get name means get element name. This is element name property. Will get it because this is a setter. This is a getter method, this is a setter method on a Java. Then we will get this property element right here. Then we will set it to new header. then we will copy all the three right now. Whatever those three is, we say new header dot copy element 3, like whatever the header has, this header that was the first child, they will assign it to my new header. Then we will move it to next sibling. My next sibling is this one. It said header dot get next sibling and assign it to header. We just swipe it over and we will recheck again. We will get all three right here and sign it. But let's write our own code. This way we will write it. First, I want to create parent, then first child and second child, and I want to write it as a XML domain, like XML NEC. So how we do that? Again, we must say MB element. Let's get out from the. It said MB element. Control space, they will come. And first I will call root because I want to create my root, equal to, because you see we have already created empty message, new empty. We will use out dot, then we create the root element. After this one we just create up to this point. So what should I do again? Then I want to create XML NEC. If you want to create XML NEC MB element, then I call them XML NEC domain. You could call them anything domain. Then this XML NEC coming under this one on the root. So we will say root dot. Then because we created as a last child of this one, there would be only one domain. I just want to get XML NEC. I want to create only XML NEC, nothing else. That would be last and first or whatever. So we'll say MB XML NEC. MB we have XML dot. We want first name, that means sign for me XML domain for me. Now we sign the XML domain to my root. So on the root, now I just get the to XML NEC. I create it right now. Now we want to create the rest of the body, parent, child, and child, second child. How we want to do it? Again, we will say MB element. MB element, we just type it parent, and this parent is coming on the domain because it's a child of domain. Then again it's a create, because this also is because there is only one parent. If there was second tag of parent, that would be a first tag and another one would be second, the third would be last, or the middle would be a next sibling. But since there's you call them first child or last child, either way is fine. I will call him last child, and we'll say MB element. This type MB element because it's not domain, is an MB element. This is the element. Then we have a three type of function right here. We have a type name value. Only when I say type name, they only will get the element name. There's a property element name that says they will get only the element name. When I say type name and value, they will sign like right here name and value. We must sign name and value right here. But if we sign only value, they only asking for value. But right now we will sign name and value. How we want to do it? We on the first quotation we write the name of the parent. Our element name is parent, and the value, if there is a no value, we just sign them null. And one thing I want to mention, it is very clear. It must be what happened? What happened? Yeah, I didn't save it. And parent XML domain create as a last child MB element dot value pair parent and null. And all those tag has a name value pair. Right here is stored name value pair. Make sure everything is this is the name, this is the value. Then on this one, this is the name, this is the value. Like here, everything has a name value pair. Like all the tag is a name value pair. Every tag almost. And now we come to a child. We want to create child. and MB element again, just give them first one child, and again the child is coming on under the parent. We just want to use parent dot create, because this is the first child, this is the second. I will say first child. I will say then this is also MB element. MB element dot, there's a name value pair again. The name is child, and the value is, let me copy and paste. The value is first child has a John name. We assign it to value, and let's work with the second one, second child MB element. We have a second child, and second child we name them, and this is also coming on the parent. We call them, and this time that was the first child, this is the last child, because the second child there's no other child below that. This is the last child, and last child we for no bitstream create element as a last child, and there's also MB type element because it's an element type, and as a value name and value. Name is child and the value is a Habib something. Copy and paste, save, and let's deploy it and see. Let's complete that one because we're not working with anymore with this. Complete and go to debug prospect and deploy. I hope it work. Okay, and let's do message. Send this message only one tag I. Now switch to domain. Let's get into, and up to this point you see we create this as object. We create in assembly all the message coming from MB message assembly out terminal. We create, we sign out terminal to end message. We create all the message we get it from M assembly to end message, and we create empty. And we let's run our out message assembly, copy tag, and just say let's run it one more time because I see resume and complete that one. Let's see it. You will see it. We see that this is the first child and last child. Let's run it one more time. You will see that on a debug prospect. Let's get it and go on a header. Now let's check that one. Up to this point, one more thing. And when I say root, just pay attention. Root they create is 1000. The type is 1000, and they only say name root. We create only root, which the name is only root, has no value. That's why there's a root. And we create the domain right now. If you check domain, also the name is domain. There's 1000. The type is 1000. And if you run the another one, parent, we create parent, but the type is parent, and the name is parent, has no value. It is null, which we did the same thing. And also now we create 1000. That means it's belong to domain. This one is belong to child, is belong to domain of XML. So another type, this also belong to domain. If you check the child, is a name. Name is a child and value is this one. And let's run the second child. And I just complete it and propagate it and done. Stop and resume it. Is done. Let's once again run it and check the message. Cause completed and see the message. See, parent we create as a child. First child as a John name. The second child has a Habib. So on the next video I will create, instead that we hard coding, how should we get this data right here and we get data from in message from the input and sign it to our output message. So see you on the next video. On the next video will be based on this one. Thank you.